All right, welcome everybody. Thank you so much for joining us today. This is the webinar about our series of Postgres 101. We've been doing these now. I think this is the fifth session we've done, trying to bring this new information to the community that Redgate has so often been a part of. SQL Server particularly. We know there's so many developers and DBAs and people within the space that are beginning to explore Postgres. And we want to do what we can every month just to give you a little bit more information, ways to help in your exploration of this new database, and particularly if it's something you need to do for your work. Okay, so today's session is about extensions, 10 extensions you need to know about. So if you've joined into the other sessions we have had over the last number of months, a couple of them we've talked about this idea of extensions. And so we're going to go ahead and get into that today. So before we get started, let me get focused here. This is who I am. My name is Ryan Booz. I am a developer advocate at Redgate, focused primarily on Postgres and database DevOps. There's where you can find me. I do still exist. I guess I need to change that icon now to X, but I do still exist on Twitter. I have a blog that is fairly active, and every so often I might stream on YouTube and so forth. So please don't ever hesitate to reach out, particularly if some of the things you learned today or you hear about today want more clarification or some way that I can help you in your next step of the journey. So today we're talking about extensions. Next month, near the end of the month, we're going to talk about the Postgres documentation. It is very good, deep, thorough documentation, but it can be a challenge to navigate sometimes. And that, again, someone who's gone through this journey has had to understand how to dig into Postgres. I think Grant might join me on that one, and we're just going to talk about the Postgres documentation, what that really looks like. Couple quick housekeeping reminders. This session will be recorded and it will be made available to you after the session today and in the future. If you want to look at it on demand, you can do that through the Redgate website. And any questions you have, you can go ahead and do into the Q&A box, and we will go ahead and get to them at the end of the webinar. So here's the brief agenda for today. This is not going to be a very long webinar, probably 35, maybe 40 minutes tops. We're going to talk about what extensions are within Postgres. It's a unique concept and something particularly coming from a database like SQL Server you are probably not used to. We're going to briefly talk about some of the problems that extensions can solve. Why do they exist? I'm going to show you again how you can install them, what that looks like. And then I'm going to go through 10 extensions to know about. And I'll have my disclaimer when we get to that section that it's really hard to choose 10, but I will give you 10 that I think are at least worth understanding exist and might be helpful in some form or fashion. All right, so let's go ahead and get started. If you have watched any of the previous sessions, and if you haven't, I encourage you to go do that. I've shown slides like this in a couple of talks over the last year or so. And for me, this is one of the 2 or 3 big highlights about Postgres and why it has become so versatile within our space today. It is the only major database, relational database, that allows this concept of extension, changing or adding to the database environment something that on your own that can change the way that Postgres works, that can take advantage of the core code. And so it really is a unique feature set, and that's what we want to start to think about today. So extensions are just that. They are non-core code that can be installed into any database within the Postgres cluster. So that means that for the Postgres community is spending every month of every year developing, enhancing, and improving Postgres, the open source code base. Over the last number of years, actually going back close to 12 or 13 years, they provided this opportunity to hook into the database at certain execution points. For instance, when the Postgres determines the query plan, there's this code hook that you could create an extension to say, hey, when you're generating the query plan, let me see it first. I might want to influence it, whatever that extension is doing. And so there's a lot of versatility and what extensions can do. They can actually just be really simple. It can simply be an extension that just adds a new function or some kind of new minimal feature to the database. And why you would want to do this is hopefully becomes clear as you go through some of these next slides. So they can be written in any supported language, including SQL. So that means and it's fairly well documented how to do this. It's actually not terribly difficult. You can create your own package. You can put it on the server that Postgres is running on. And as long as it's in the correct location, you can then install that extension into any database within the cluster. So as a DBA, you might have a set of functions or store procedures that you always want to have available in all of your Postgres databases, for some kind of maintenance task or views or things that are essential to you and your work and your job. Rather than having a script that you have to run database by database by database, and you're not sure which script you've run in every database, you could install it as a function, as an extension, and then you simply create the extension in every database. If you create a new version, maybe the scripts get updated, you can install that new extension, which is simply just all of the store procedures you normally would use for your work. And so you can maintain and version all of those things. So it's really, really interesting. All of the popular extensions we're going to talk about today, most of them at this point, that is changing a little bit, are often written in C. But again, you can actually create extensions in any supported language that is on that computer that Postgres is running on. C will get you the best performance. That is what Postgres is written in, is ANSI-C. And so that's just what a lot of people do, if it's a production level extension for some reason. But again, you can use any language. And the new entrance into this game, probably the last 3 years, has been the PGRX framework. It is a Rust-based framework specifically designed to allow easy and performant creation of extensions. So it's really helped open the doors for companies to create new extensions, do things that honestly were pretty difficult to do previously unless you were really, really good with the C language and understood the code base. So it's a really interesting and neat extension, and it's gotten a lot of use lately. So go ahead and try and check that out. There's lots of good tutorials and examples. So that's what extensions are. They are a source of a chunk of code that does something in our database, whether it's just simply adding a function or store procedure, or actually asking Postgres to let me maybe influence how it's running at some point. What are the problems that we're trying to solve? Well, I already talked about this first one, right? I've seen this often, that companies, teams of DBAs, they will actually create an extension which has all of their, whatever it might be, their extensions, store procedures, so forth, their functions, store procedures. And then as maybe a store procedure is modified, they don't just open up a script and go run it in every database. They update the version of the extension, install it on the computer, and then they can update, we call it altering, the extension version, which will make sure the newest code is installed within that database. And it's neat because you can actually track the extension version, so you know which version of your, in this case, store procedures inside of each database. So it's really helpful. So that's one use case I've seen a lot. Providing access to data on the server. So there's a number of extensions that deal with metrics. Postgres is tracking lots of things, but the core open source developers don't always have the time or the energy to expose all of that data in maybe the way that is useful to everybody. And so many, many people have created extensions that will surface that data in some form or fashion. There's also extensions that one is called Stat Kcache, which allows you to actually get statistics about the underlying computer inside of your running Postgres instance. And so there's a lot of opportunity there, and you'll see a lot of those kinds of extensions. Modifying data storage. Again, there are some really big, elaborate extensions that actually kind of create a new version of Postgres to do something new. And some of them, when you create a partition or you create data, they can actually modify how it gets stored and saved to disk for some unique form or reason. One might be compression. You want some kind of data to be compressed in a unique way, and an extension can say, hey, before you save this kind of data, let me see it. I'm going to do something to it, and then you can go ahead and store it. Lots of interesting things you can do there. And then the biggest one that I see a lot is influencing the query planner. Again, if you're coming from any other database, this is unthinkable, that as a user, you could install an extension that might do something to improve or modify what the query planner is doing with the queries that it's running. There are a lot of good reasons that you might want to do this, a lot of good opportunity. And so again, I'll talk about one or two of those as we go, but these are just some ideas. There are certainly more. but you'll see a lot of these kinds of examples as you start to explore extensions in Postgres. And the thing I would say is this might be a bit of a strong statement, but if you wish Postgres or the database you're currently using could do something, it probably is possible with an extension within reason. And again, it's just beginning to know. It definitely takes programmatic acumen in whatever language you're using, understanding the framework of Postgres. But there's a lot of people that do, and they're creating these extensions over time. They can be really big. And so I just gave 3 quick examples. I used to work for TimescaleDB. It's a time series database built on top of Postgres, and it is entirely done through an extension. So you can install just plain vanilla Postgres, install the TimescaleDB extension, and install it into your database, and you magically have all the features of TimescaleDB. Same thing with Citus. So Citus is actually what runs the Microsoft platform for Azure Cosmos DB for Postgres. It is a horizontally scalable version of Postgres. You can have multiple nodes. You can shard and partition data across multiple nodes. You can query any node depending on how your schema is set up. There's lots you can do with Citus. And Citus is just an extension. It actually years ago was a fork of the Postgres database. And then when they realized, that the hook framework inside of Postgres was powerful enough, they actually took the effort to turn all of that code into an extension. So now they could just use vanilla Postgres, install as an extension, and they didn't have to maintain a separate Postgres code base. And then last, probably one of the most long-standing and effective or used extensions in the Postgres space is PostGIS, mapping spatial data and what have you. It's very powerful. And honestly, is one of the kind of the gold standards of using a database for mapping and geospatial data. There are lots of commercial products like ESRI that are really popular and obviously very expensive. And PostGIS does a lot of really amazing stuff, and a really dedicated team that continues to make that a great product. Okay, so we have a basic idea of what extensions are. They're code that's not included by default with Postgres, but can be installed, can do something to Postgres. A couple examples of why you might want to do that. And so now let's say you have a Postgres database somewhere, and you start to hear about some of these extensions, and you say, well, how do I install it? What does that look like? A couple quick things to understand. So Postgres, if you think about the server that is running the process of Postgres, the database, the extension has to be installed, the code has to be installed on the server itself, right? Outside of Postgres, it just has to be in the right location so that Postgres can see it as an available extension. And then the extension is installed per database. There are no server level extensions. Extensions require a database to do something to. Now, Postgres, the platform, the actual server, actually does ship with probably 20 to 30 extensions of its own, right? So things like, well, I'm going to talk about a couple of them, and you'll see that, but statistics views. There's some views that are not exposed unless you specifically do it inside of your database. Say, in this database, I want to see these statistics of, metrics of query processing and so forth. So anywhere that you have a Postgres installation, there are at least 20 plus extensions that you can install should be without any issue. Again, permissions might refrain you from doing that at some level, but generally, if it's in the contrib package, then you should be able to install any of those extensions for the most part. The other way you can install extensions on the server so that they become available within the Postgres runtime is you can do it manually. So if you're running a computer, a Linux server, for instance, and you have access to create or compile these extensions from source, or you have a package manager, many of these extensions are available through those means, and you can install them. They will get installed to the right location, and then they're available for you to use. And then there is an open source network called the Postgres Extension Network, which I'll show you in just a few minutes. And that's, again, an open source project maintained by the community. And so community users, there are probably 300 or so. I think I'm correct on that number. There's a lot of extensions on that website within that network. And so think of this like a package manager for your language if you're a developer, whether it's .NET or Java or Perl or Python, whatever it is, most of those languages have some kind of network that you can install packages from. And that is the idea behind the PGXN network. So users, developers can upload their extensions to that website, and they become available through an application that you install on the computer to do an install of the extension that makes it available. And then the last thing to know is that some extensions, many extensions are trusted, some are trusted, and a lot are untrusted. And all that means is this: there are some extensions, particularly the language extensions, that allow you to write store procedures and functions, say in JavaScript or in Python or in Rust, whatever those languages are. Those are almost always included as an extension. Some of them are untrusted because in order to run, they actually give you access to the underlying operating system, because the language allows you access to the underlying operating system. And so in some environments, if an extension is untrusted, they just simply won't allow you to install it because, again, in the cloud environment, we don't get access to the management rights of the server. And so if they allowed us to use some of those extensions, it might provide a security backdoor to do something they don't want us to do. So just recognize that exists. Sometimes you'll wish an extension was available in some environment and it's not, and it could be because it's untrusted. So to actually see your extensions, it's available through a view called PG Available Extensions. You can simply say select star from, and then I often order by name, otherwise it's hard to parse through. And that will show you all the extensions that are currently available from that server that can be installed into your database. And it will show you any that are currently installed and what version is currently installed in your database. And then when you want to install an extension, let's say again, you want to make pgstat statements available to view within this database, you simply say create extension and name the extension. Now you can also name the specific version of the extension. And again, some of these extensions are updated often. And so, if you want to keep up with the newest version, newest features, you may be installing new versions every time. You can update it by doing alter, and you can drop an extension, essentially delete the functionality from your database by saying drop extension. Now, I will say this: support varies among cloud providers. And it really matters what the environment is, the way that they're providing Postgres to you. So if you are spinning up a new instance of Postgres in Aurora, or in Azure, or in Google Cloud, or again, wherever that might be, you will have to go look and see which extensions that they actually provide support for. And to show you that, I just want to run through a couple quick tabs. So this is Amazon's website. You can see, I can just look this up. You can just say Postgres available extensions in RDS, and it will show you which versions are available, what they can do. It has a link to that extension, so you can read up on what it is. There's a lot here. And Azure does the same thing. They'll show you the list of extensions available. This is one of the networks, one of the providers I talked about previously, Neon Database, which is a Postgres database. Again, so you'll see this over and over again. And then this is the PGXN website that I talked about. You'll see there's lots of user-contributed extensions that if you install this server level on the server, this tooling, you can it's kind of like Python pip, right? You can say pip install for Python. You can say pgxn install and name the extension, and it will download and install that extension for you. And then the last thing to say about managing extensions before we get to the 10 extensions is that I've mentioned a few times versioning. Extensions can be versioned, whether they're ones you create, as I've said a few times, maybe in a database team, you create an extension for all of the scripts you always want to have available. And if you update that script, you can update the extension version so that you can track which one's installed. Now, for a commercial product like Citus or Timescale, they might have an update every month. And if you want to keep up to date, you keep installing those updates. If you happen to do management of your database, and obviously we are makers of Flyway, knowing the version that you are expecting is really important. Because unless you specify the version, if I were to be working on my personal laptop, I install an extension for a new feature we're developing, and my script simply says create extension X. When I run that script on another server, it's always going to install the most recent version that's on that server, unless I name the version. And so you might run that script on production, and it turns out it has an older or a newer version, and your code might not work as you expect. And so we know this. And so within Flyway, we actually do track with Flyway teams in enterprise, we track those dependencies. If you are updating and installing extension, we will actually help generate those scripts that name the version so that you are sure as that schema gets progressed and installed and updated through your lifecycle, that you know what version you're extension based on the code that you've written. So check that out. There's an article we wrote about it recently, just keeping track of extension versions and why it's really important. And so now we're going to go ahead and jump into 10 extensions to know about. Now, I said I would give you a disclaimer when we got here. The disclaimer is, if you look up on your search engine of choice, top 10 extensions for Postgres, you'll get a different list from many different websites. We all love to talk about extensions. We love to talk about which extensions are really helpful. So this is, some of these I just know and I love. I think they're really standard. You need to know they exist. Some I went to all of, 4 or 5 of the online providers to see which ones existed across the board, what might be interesting, and so forth. So this is not a definitive list, but I think some of these are really valuable for you to know about as you begin to look at Postgres. So first and foremost is PostGIS. And I say this because you might not have anything within your work life or your application that is based on time and space, right? Location and geospatial data. But PostGIS is such an amazing extension. It can do so many amazing things with geospatial and spatial data in general that it's just interesting. And I think it's really nice to know it exists. And there's a whole community around PostGIS that you can learn. So if this is something you ever need to think about, just know it exists. When you install the extension, it adds lots and lots of functions, and it adds new data types and new index types so that we can efficiently query geospatial data. It might simply be for mapping. It might be to find actual routing, point A to point B. It might be to find points on a map that are close together within a specific region. All of those things are possible given location information using the PostGIS extension. And in fact, I'm really excited because this year at Past Summit, Ryan Lambert is giving a full-day pre-con on PostGIS with PostgreSQL. Ryan is a longtime SQL Server DBA, but he has had a huge interest in geospatial and mapping for years, and he is a very vibrant member of the PostGIS community. And I would say probably one of his true loves is PostGIS, even though his day job for many, many years has been a SQL Server DBA as well. So he's going to really come with a lot of knowledge and experience to this pre-con, which will allow you to learn a little bit more about Postgres and this really interesting this new extension called PostGIS. And he's going to do it in a way that he understands, particularly SQL Server DBAs and their experience and where they're at. So please consider checking that out. It's going to be the first day of Summit on Monday. It's going to be full day pre-con. I hope to be there and just be in the room and help, but it'd be really interesting. I think it's a really neat opportunity if you've never explored this new technology. I say new, it's not new, but if you have never explored PostGIS, it's new, right? And so, this is just an example I pulled from actually one of Ryan's projects that I talked to him about a little bit, is creating fake data, but that's realistic, actually exists on streets. So you can create what seems like real points of information for residences and for businesses and industrial sites and so forth. And so you create that data, and then it's really easy to pull this up in tooling and show these kinds of points through queries on a map. Lots of other fun stuff you can do, but that is one example. All right, number 2 is Postgres FDW. So I want to note this little up in the right-hand corner, top right-hand corner. Anytime in these next few slides that this extension is part of contrib, so it's shipped with Postgres, I'll put that little logo up there just so you know, if you have access to Postgres right now, there's a very high chance that you can install this extension without any issue. So the Postgres FDW is basically a way to, it's a foreign data wrapper. So it's a standards compliant connection infrastructure. And there are many foreign data wrappers. There's a SQL Server data wrapper. There's a Mongo data wrapper. There's a Redshift data wrapper. I mean, there's so many data wrappers that allow you to essentially connect to a different database, or there's a file data wrapper, an S3 data wrapper. There's so many, but it's a standard way of creating those connections so that we can query and retrieve data from other data sources. And so this specific one initiates a connection to another Postgres database. And the reason it's necessary is this: in Postgres, if you've come from SQL Server, that might seem like, how is this possible? There is no fully qualified notation that allows you to reference a different database on the same server. And so in the MySQL Server space, if I have two databases, I can just reference a different database as long as that connection has permissions and what have you. In Postgres, that's not possible. You have to have either something like Postgres FDW or DB Link in order to connect to and query a foreign table in another database. So this is really essential for doing your work. The great thing about Postgres FDW, there's a lot more effort that's gone into this extension for doing things like predicate pushdown. So if the query is formed correctly, it will do its best to send over to the other server the predicate so that the filtering is done there, rather than pulling all the data back and then the filtering done on the local server that you're connected to. So there's a lot of really good things to learn and know about with Postgres FDW. And if you ever have a need to connect to either insert data in a different database or read data from a different Postgres database, this is probably your go-to tool. pgstat statements is number 3. Again, this is part of the contrib module. And this is by far, any survey you've ever seen, probably the most used extension in Postgres. And the reason is this: it is not enabled by default, and that was done years ago because it does add a small bit of overhead to the database for tracking query metrics. And the open source team doesn't feel that it's their job to impose additional overhead unless it's essential and necessary. And so they make this available as an extension. This creates a view that you can use to see the data that is being stored as you're running queries in your database. Things like number of rows retrieved, how many times an index has been scanned. For a parameterized query, much like we would see, kind of like we would see in Query Store or something like that in SQL Server. The one issue with pgstat statements is it is cumulative only. There are no snapshots happening, right? There is no such thing as Query Store in Postgres. And so if you want to track metrics for a query over time, then you need to take snapshots on your own or use a tool to do that. By default, this is installed in every major cloud provider that I know of. So if you go to Azure, you go to AWS, wherever you go, as far as I know, every cloud provider does provide access to this extension so that you can install it. Sometimes it might just be installed by default for you, and you can query these metrics. Now, it is essential because any monitoring solution that you get or you use with Postgres is very, very likely going to need at least that extension to be installed, because those metrics allow us to do things like this. This is SQL Monitor, monitoring a Postgres database. And you can see that we can take snapshots over time. We can look at the query and see the execution times of that query over time. If you try and do this on your own, you're going to have something that takes that snapshot every so often, stores it in the correct tables, does that work, correlates it to a query. So whether you use something like SQL Monitor or another open source tool, all of them are probably going to pull from pgstat statements. Number 4, I'm not going to be able to keep count, I don't think, but I'll try. pgcron. So Postgres does not have a built-in job scheduler. We are used to having SQL Server job, the agent, to do that work for us. We can schedule agent jobs to do whatever we need, run a query every so often, do database maintenance, whatever. It doesn't exist in Postgres. And so there are a couple of extensions. The most popular one at this point still seems to be pgcron. And again, this is almost always available on every cloud provider that I generally would say I know or work with. And so with pgcron, you can install it. You can then create jobs that run store procedures, execute scripts, do lots of things. And then other extensions that might need to do something on a time basis don't often do it within their own extension. You will often see in instructions, install pgcron and start a job like this, which will execute this extension to do whatever work you need. And we're going to talk about pgpartment in a minute. That is an example that always references using pgcron to do automated timed work. And again, it's available on all major platforms. Number 5 is pgtrigram. So this is just really interesting to me. Like I said, many extensions deal with things like new data types, new index types, and this is one of them. So you might not know what a trigram index is, but if you think about a word, any of the words you see on the screen, it's a matter of breaking the word apart into sets of 3 letters. So the word provide, if I broke that up into a trigram, would be PRO, ROV, OVI, VID, and so forth. And it would store each of those chunks, including or excluding spaces, depending. And then that allows you, if you build an index over that, to quickly search for words without having to do the, delimiters on both sides of a query, which isn't very performant, doesn't really use indexes. And so it's a really neat way to do searching on textual words. This is not a full text search. I wouldn't recommend it for that. But let's say you have a product and you have hundreds and thousands of product names, and you want people to be able to start to type anything within that name, and that word comes up in the search. That's a really good use for trigrams. So, I've done trigrams before in SQL Server manually by creating the tables and the indexes and the processes. This is just built in as an extension to Postgres, and it's included in Contrib. It is, again, best for smaller text fields. The indexes do get pretty large, and so it's just something you're gonna have to maintain and understand, but can be really, really useful. HypoPG, I think this is number 6, is one that I just really think is interesting. How many times have you worked with SQL Server and you think based on what you're seeing in query plans, you're seeing maybe in Query Store, that it would really help to create this kind of index, maybe an index with included columns or a multi-column index, but it might be expensive. It might be on a really big table. And so to take that effort, unless you have SQL Server Enterprise, it's not going to be concurrent, right? So there's going to be locking issues. Wouldn't it be amazing if you could create this index, run a query to see if the planner would pick up the index and actually make a difference? That's what HypoPG does. So you install this extension, you create an index with the functions of this extension, and then when you do an explain, so it's not an actual query, it's it's just the proposed query that is planned by the planner. When you explain it, you'll be able to see if the index you created was picked up and was used. It supports many types of index variations, multi-column, included, different index types, what have you. It's just really interesting. Actually, about a month ago, someone reached out with some questions about a performance issue on their database. And I spent an evening or an afternoon, I was in a hotel room, I think, at a conference. I created a much smaller version of their database, just like 2 or 3 tables, created fake data, tens of millions of rows, just so I could see if the index I was recommending to them would modify the query plan in an efficient way. So it's really neat to be able to do that, show them without ever having to touch the database and experience locking or downtime. Again, your mileage might vary, but it's a really, really interesting tool. And again, many of the hosted environments do allow HypoPG as well. All right, pgpartman. So Postgres does support partitioning. It supports it natively, but it's not automatic. So if the partitions don't exist before the data arrives for that partition, then it goes into this holding table, and it's not, it just takes a lot of management. And so again, right now, in order to pre-create the partitions that are necessary in the future or in the past, maybe you're loading old data, pgpartman is, again, one of the extensions that's available everywhere that I know of. And with a few commands, you can set up, in addition to pgcron, automated jobs that will make sure partitions exist for when new data is coming in, maybe archive and drop older partitions, and a number of other maintenance things you can do. So it's a really useful and powerful extension for managing partitioning with a couple commands. In many ways, partitioning in Postgres is actually a little bit easier in my experience than trying to manage it within SQL Server. But a lot of opportunity here for you to use and do a job with partitioning. Now, PG Vector, I bring this up not because I actually have much experience with it yet. I've played very briefly, but the vector space right now is huge. We're learning about generative AI and large language models and using a database for these kinds of data types and data stores and being able to query them. PG Vector is a fairly new extension, but allows you to actually store embeddings from large language model in your database and query them for similarities and query them for opportunities of what that means within the model. There's a lot of focus and attention happening right now. And again, PG Vector, if you Google that or whatever your search engine is, Bing it right now, there's a lot of talk around PG Vector and other extensions that are coming out right now, just in the last weeks, around large language models, AI technology, and vector data stores for doing this kind of work. Check it out. There's some really neat tutorials, some good demos that you can find online. And if this is interesting, if this might be something you're looking at within your organization, there can be some real opportunities here. One of the last ones to talk about then is PG Hint Plan. This is getting more attention lately. It's actually been around for quite a while. I believe originally written, a developer out of Japan had created this. And Postgres does not support query hints. Again, I've talked about this in previous webinars. It's just something that you currently have to understand. The team that has developed Postgres generally believes if the query planner can't do a good job based on the available statistics and information, then the planner should be improved rather than providing lots of query hints that kind of subvert what the planner should be learning. Well, that doesn't always play out well in real time. And so PG Hint Plan is an extension that allows you within the query to do Oracle type, Oracle syntax. It's like Oracle syntax. So in Oracle, you can use comments to provide query hints. And so that's what this extension does. Again, if you go to the GitHub repo for this, you'll see examples. There's for some reason, a lot of recent blog posts across the community about PG Hint Plan. But it's an opportunity. So if you really need to change the way that your query is being executed without going through lots of hoops, you can attempt to tell it what kind of join and what kind of index or which index to use. So it's worth looking at. And again, most cloud providers do give you access to this if that is where you're at. It certainly won't solve every problem. It's not magic, but it might be helpful depending on what your application is doing. And then the last one I'll talk about, which is part of crypto, and then I do have one bonus next, is PG Crypto. So transparent data encryption, TDE, is not currently supported in vanilla Postgres. There are a couple of forks of Postgres from various companies that do support transparent data encryption. It is an active subject of development. There have been a couple of attempts to figure out how to do this well in an open source project, how you manage keys and all of those things. I believe it will come eventually, but if you need to encrypt data at rest in some way, maybe it's specific fields, you can use PG Crypto. It's part of Contrib, and it's widely used as a way to encrypt data, one-way encryption, or hash information if you need to do reverse hashing and so forth. There's some examples of why you might need to use it, but again, it comes up often. The subject of data encryption comes up often, and so it's just good to know that it exists. And if you ask online, how do I encrypt, the social security number in this table or whatever it might be, you'll likely get an answer to at least look at and start with PG Crypto. And then I have one bonus for you, and part of this is because we get a lot of questions about it. These two databases, TimescaleDB and Citus, as I mentioned earlier, they are actually simply extensions that you install into a vanilla, regular Postgres database, and you get a whole new set of functionality. Both of them, they have a different approach to a similar problem. Timescale I used to work at is very focused on time series data, and when you have enormous amounts of time series data, you almost always have to eventually partition that data in order to stay performant and manage archiving and all of those things. Timescale helps with automatic partitioning, so you actually don't need the PG partman, but it's only for time series data. But what that means is as data flows in, if the time bucket is not available for the data that's currently coming in, Timescale will create that partition for you and then just keep flowing along. And so it's a really helpful tool if you have large amounts of time series data. It has some really cool extension features like continuous aggregate. So a materialized view that is just maintained both with new data and any modifications to old data, has compression, all those kinds of things. Citus is really about horizontal scaling, more partitioning plus sharding. The team, it was acquired by Microsoft a number of years ago. The team is really excellent. They have really good content. They run an online virtual conference 2 years in a row now that has just been really, really well done. You'll see them at various conferences. It's a really neat extension. And if you have large data sets, you have things like tenant partitioning. So maybe you have an application that has many tenants and you want to be able to partition based on tenant, based on schema for the tenant. There's all kinds of things that Citus can do for partitioning and sharding. It also has some neat compression capabilities, things that query any node so that you can actually connect to any of the nodes within the cluster and do some forms of queries, not just through the master, the main primary node. So really interesting. Again, I'd just encourage you to go look at both of these companies and their websites. Some really neat things they do. As someone who used SQL Server for 15 years, often with time series data, and I always wanted to have a little bit easier job partitioning and managing. From Postgres perspective, both of these have some really neat opportunities and would have made my job in some of those applications a lot easier. All right, so I'm going to go ahead and pause for a minute and get ready to look at questions. Make sure you're typing them in there. And then what I'm going to do is, again, I don't have my normal setup, so I'm going to put my phone up here so the team can feed me any questions we have. And while I'm waiting on that, I just want to give you a couple of reminders. So first, Past Summit's coming up. It is currently open for registration. The whole, the schedule is online. You can see the pre-cons. All of that stuff is available. And just encourage you to go think about registering, talk to the team, see what's happening. There's so much neat stuff that's getting ready. So we'd encourage you to think about that and move forward. Talking about what's coming up next on September 19th, again, we're going to talk about PostgreSQL documentation. Again, Grant might join me, and we're going to just talk about how you can more effectively use documentation when you need it to learn Postgres. And last but not least, we have the State of Database Landscape Survey. So over the last many years, Postgres Redgate has done the Database DevOps Survey, gotten some really neat information out of that. But we realized that what's really happened over the last couple of years with this proliferation of so many different database types and many cloud providers supporting many different types of databases, a lot of our jobs are changing. We're not just using one database for everything. Maybe we still have an application database we've been using for 15 years, but the analytics team now wants to use Snowflake, or they want to use Redshift, or you want to explore Postgres for this new application as a greenfield project. And it's really become possible. And so we're finding that teams are now having to manage 2, 3, 4 different kinds of databases. Their skill sets have to change, and just how they work. And that's the purpose of this database, is to try and understand what some of those changes have been. So really encourage you to go take part. The more people that do, the more information we can glean. So, all right. So it looks like maybe there's no questions. I hope that means that we've covered things well. And there's just an opportunity to learn a little bit more about what Postgres is doing. And as always, feel free to reach out. You'll find content from us on Simple Talk. You'll find content on my blog, Grant's blog, other blogs. There's a really good, vibrant community. And again, I'll put a plug in just from community perspective. I started a year ago something analogous to the T-SQL Tuesday blogging event that has happened in the SQL Server community for 12 or 13 years. I call it PG-SQL Friday, PH Friday, trying to do the same alliteration. And so at the first Friday of every month, we blog about a specific topic. We put the invitation out, anyone can contribute. And this next month, at the beginning of September, I'm hosting it because it's the 12th, it's the end of the first year. I'm asking people to talk about their favorite upcoming feature of Postgres 16. Postgres 16 should be released in about a month or a month and a half, usually around the beginning of October. And we just want to get a handle on what is everyone really excited about? What's the new thing, or what has been fixed or updated in some way that allows them to do something new with Postgres. So look for that as well. Thank you so much for taking the time to join us today. I do hope this was informative, gives you a little bit more of an idea what Postgres is, how extensions work, the opportunity with extensions, and allows you to move forward in a new way. Thanks so much for your time today. I really hope that you have a great day and a great rest of your week. Take care.